Hi everyone. Today I'm going to be talking about an old A-level question from 2016. Now this is from paper 3, question 9. Question 9 part E in particular. Okay. Now this question involves binary stars. I hope you know what binary star is. If not, I will show you what it is later. So in this question, what we see here is that we are given two situations. Situation 1, situation 2. In the first situation, we have a binary star where the plane of orbits is normal to the line of sight from Earth, and the second one, it is plane of orbits is parallel to the line of sight. And not only that, the binary star is also too far from Earth such that the individual stars cannot be differentiated. Okay. Now, what does this mean? I'm going to show you in the next slide. So have a look here. This animation, right, is taken from a program that I downloaded from the Steam store. You can search for it. It's called Space Engine. It's pretty cool because you can basically just zoom in and view all the different planets and stars and constellations and all that you can find. Okay, and then they will give you some interesting data on the side here as well. So binary star, right? So first of all, what is a binary star? Binary star is basically a system of two stars that are close enough together such that they are orbiting each other, right? They are orbiting a common center of mass. So you see here, you have a slightly larger star called Draconis AA, and then it has a partner called CM Draconis AB. And basically, they are orbiting each other about a common center of mass over here. Okay? This view that we see here is the view that you will get if our line of sight was perpendicular to the plane of orbits. Okay, so what is meant by plane of orbits? Plane of orbits basically means that when you are looking at these two stars orbiting each other like this, they are basically doing this, right? So they are orbiting in this plane that is like sort of perpendicular to my line of sight to it. Okay, so this is what is meant by perpendicular to the plane of orbits. Another thing to note is if we move very far away, so if we zoom out really far, you can see that the further you are away, it can be quite difficult to distinguish between the individual stars, right? Now you still can, but I'm sure you can imagine that if you go further away, you can't distinguish anymore. You'll just look like one bright dot, okay? So next, what we're going to look at is we are going to see what is meant by parallel to the plane of orbits. So this is still perpendicular to the plane of orbits. Parallel to the plane of orbits would be like this. So if we rotate our point of view, and then we sort of look at it instead of like a top-down view, we look at it from a sideways view, like this, right? So now the stars are orbiting in this manner, right? So the plane of orbit is like this, and we're looking at the plane of orbit from the side. So this is what is meant by parallel line of view to the plane of orbits, okay? And so you will notice that instead of seeing two bright dots moving in circles, now we are seeing two bright dots like sort of like crisscross each other like this. And so this is actually the big clue as to how to solve this question. So now we are zooming out. So like the question mentioned, right, if you are very far away, it's too far away for you to distinguish the individual stars. How do we then use this to determine the period? So the clue is in the fact that one star will pass in front of the other periodically, right? Because now we are viewing it from the side. So let's have a look at a graph. Like if you try to imagine this on a graph, what it will look like is that if you point some like very sensitive telescope at where that star system is supposed to be, and you measure the intensity of light that we are receiving from this star system, what you will see is you will receive a roughly constant amount of light coming from the system, but once one of the stars passes behind the other star, what you will see is that there will be a slight dip in the total intensity coming from the system. Why? Because when one star passes behind, the light that is coming from this star is being blocked, right? And so there will be a dip, right? So this will of course recover once it moves past this position, but then after half a rotation, this situation will happen again. The star that was originally in front will now go behind, and we have this blockage thing happening again. Okay, so we'll see another dip. So if we measure the time interval between these two dips, this will give us half a period. This is T over 2. Okay, simple as that. So how do we answer this question? We can just say that when one star passes in front of the other, the total intensity received from the star system will drop. Okay, if we measure the time interval between two successive dips, right, this will give us half a period. So I hope this animation clarifies this question for everybody. And I hope to make more videos using this Space Engine program soon. Okay, so please subscribe if you're interested in this kind of thing, and thank you for watching.